Hi, good morning, everyone. I'm Rahul David from Chipage Technologies. I'm the BDM for institutional sales. So I'm very happy to welcome all of you this Saturday morning to enhance your knowledge in the topic of AI ML in chip design and verification. And I warmly welcome our speaker, Mr. Paul Kunz from London, and he has a 25 plus years of experience in chip design and who has previously worked in US and Russia. And the best part about him is he has started two companies from scratch and built it to the next level, and he has sold it. So now coming to the next step, like we have now like going to put a pool in the chat board. So I encourage everybody to take part of that pool. Now coming to Mr. Palkun's experience, like he has a chip design. He is a chip design and verification lead engineer with over 25 years of experience in the industry. So knowledge across the complete ASIC development flow from micro architecture specification, RTL implementation, through to functional verification and silicon validation. Extensive knowledge of advanced verification, including system Verilog, UVM, and ERM, or and the use of new methodologies, tools, and flow to deliver the best possible verification solutions. Around 2 decades of extensive industry experience into architecture, design, and verification of IPs, subsystems, SOCs, ASICs, FPGA, test chips, and VAPs. So I heartily welcome Mr. Paul to for this webinar. And additionally, he has 2 years, over 2 decades of experience in the architecture, design, and verification of IPs. So, like once again, I heartily welcome Mr. Paul. Now over to him. Thank you.
Thank you, Rahul, for the kind words. Good morning, all. I hope it's very clear to everyone. If there is not clear, please put it in the chat, and I think Rahul and others will help us. So I will be starting from, our topic for today is AI/ML in ASIC and SOC design verification, right? So I will start to share the presentation. I think that will be good. Okay. So the topic for today is AI/ML in ASIC and SOC design verification. So it's my pleasure to do this. I have spent, as told already, I've spent 2 decades in this. And basically, I've gone from architecture to tape out. I've taped out around 20 chips. And that's the experience I want to share. And also, very important is intersection of two important technologies, semiconductors and AI/ML. I think these are the two things what's happening in the world. And I think if you use AI/ML to do the ASIC SOC design and verification, we'll be more efficient. We'll be able to have a high productivity. That's the whole idea about today's presentation. First, I would like to tell about the importance of the semiconductors. We all know it, but I just wanted to emphasize. Today, if you see, there are so many devices. Everyone wants semiconductors, right? It is very clear, but I just wanted to put up this McKinsey report, which says we are going to be $1 trillion industry in 2030. So whoever are in a different stages of career, but still there's an opportunity for everyone who is starting or who is already in that. There's a huge, tremendous opportunity globally. And, globally there's an opportunity, especially in India, UK, US, everywhere there's an opportunity to be part of this cycle and to encash it and ride this wave. So what are the main areas which will be growing? It's wireless communication, you can see here. You can see the consumer electronics will be growing, automotive electronics. These are the two areas really will be growing, is wireless communication and automotive electronics. There are so many new things will be happening. So I think that's clear. We have to start from the spec. Hardware is important. The product companies all have begun to have their own chip design teams. Why? Because they have to differentiate their products by the hardware differentiation, by having the hardware. Previously, they used to do it with the software differentiation, but now they have to differentiate their products by hardware. Mainly, complexity is increasing. They have to handle huge amount of data, huge amount of number crunching is happening. So they have to have a specific hardware accelerators in their chip. Customized chip is the game today. Now, what are the great challenges? I would like to address it by seeing what are the pain points, what are the challenges, and how we can address part of it using the latest technology, AI/ML. So this everyone knows, but I just wanted to give an overview, right? Where do we start the chip? We have to understand the whole system specifications, right? What does this system have to do, right? It can, whether what problem it is solving, how it is making our lives better, right? Today we know autonomous cars are helping us to save time, right? Autonomous, semi-autonomous. Autonomous will come soon, but semi-autonomous is helping us to save time. We know we are well connected because of the social media. We know because of the good communication systems, we are able to have this platform like this, right? Otherwise, we are not able to interact. The whole world has become flat. You can interact, you can work from anywhere, remote communications, right? And then to do all this, when we're developing a system, we need to understand what problem it is going to solve and what has to go in the software, what has to go in the hardware. Then you do the feasibility study. It should be financially viable. It should be appropriate for the market. You have to market segment. And then the development starts. That's where today's topic is. When you have identified certain things, functions you're going to do in ASIC or SOC, system on chip, that is. So you need to start developing the design first. Now, the languages used for that, as you know, it's Verilog, VHDL, System Verilog, right? So olden days, we used to do schematics. We have moved on. We have come to the RTL. And when you're doing RTL, what are the things AI/ML can help or some automation can help? Some of the examples are like, we can do templates. We can do automatic, we have got CI/CD, right? Continuous integration and development. We can have construction by correct, right? While checking in itself, it's correcting few things. It's the AI/ML agents can check, it can monitor, give you a lot of data. Shift left is the whole paradigm. You're using AI/ML or automation much earlier in the cycle so that when you're constructing the design itself, the design is correct, and then you're avoiding some of the bugs. More later you find the bugs. It's more expensive in terms of cost, in terms of time and the quality, right? So we have to find the bugs as early as possible, then it shall be iterative. Then you have to prototype. Today the prototyping is done in FPGA. In the emulation platforms we do it, but then it goes to manufacturing. So one of the things very important, why verification is very important in the chip design cycle is because one mistake you do, it is not only about money, but it's about 3 months to go to the fab and to come back. And it takes 3 months. I've seen the companies close because there was a couple of important bugs, because you have lost the opportunity window to launch that product if you're not in the right time. So it's very important to make sure we have a risk mitigation plan and we verify very well, and we have all the data to make sure the chip works correct the first time, right? That is where the focus is going to be today. Package, design, testing, and supply. So this is the general flow I've put in place. Many of you may know, right? We start from the user, design and verification, vFlow, right? This is generally a macro level, right? If you go in technically, what do? We have to collect the user requirements. User requirements come from different departments. Then you have to split into software. You have to split into hardware design. Once it goes to the hardware design, then you have to do the micro level design. Micro architecture, we call it as. We have to have a detailed specifications. When you do the detailed specifications, AI/ML is beginning to help. It is helping you to document. It's a vice versa. Many companies are working in generating the spec from the RTL, or the vice versa, some basic RTL from the spec. So that's where AI/ML will start helping. To improve the efficiency, AI/ML helps you to improve your productivity, help us to be efficient. It is like a classic example is the car, autonomous car, right? They've spent billions and billions of dollars, but still we don't have a fully autonomous car. Why? Because the AI/ML is not a magic technology, but it has to learn, and it requires a lot of efforts to train it correctly and then use it appropriately. So we have not achieved in the world still 100% accuracy. Accuracy is very important in the AI/ML world. We see the accuracy up to 99%. It starts from 95 and then up to 99. It has to be accurate. That is why the life critical things are not yet possible with the AI/ML, right? It can give us some guidance. That is why autonomous vehicles, even if it comes, there's a brake override, because we should be able to control it, right? That's a classic example. Going back to the design, and then we start coding. Once the RTL is developed, we all know we have to do the IP level verification, we have to do subsystem level verification, we have to do a chip level verification. So different levels of verification we can start using the AI/ML very early in the cycle to make sure that we are efficient, we are highly productive, we are making sure that we are catching the bugs early. That's important. So some of the areas, just to give a macro level idea where AI/ML can help is to make sure your initial environment templates are generated automatically these days, especially in the system verilog UVM world. You can generate general templates, and you can also have a customized industry-specific, company-specific templates. And it is one way of enforcing the discipline of process and discipline of correctness very early, because otherwise in the olden days, the project lead used to give the coding guidelines and leave it to their whims and fancies to whether they implement it or not. But now we can enforce it and monitor it using a lot of agents, AI/ML agents, AI/ML programs, whatever you want to do, right? You can enforce it. You not only help to start it and then enforce it, that keep checking whether are they doing it, so and so forth. So then finally, it can help us in the debug. It can help us in the quality. One of the important aspects we're going to see is coverage closure. I think all of you know that in the chip design, the key thing for the sign-off is functional coverage and code coverage closure. One of the key aspects we're going to see today is how AI/ML will help us to close the functional coverage and code coverage faster. Also, how it will help us to save the resources. Resources are human resources, data center resources, computer resources, time. It will help us to be efficient. That's what we are going to see. Now let's see what are the problems due to the increase in complexity. Now the chips have become very huge. When I started 20, 25 years back, the chip used to be small, millions of gates. Today, billions of gates are there. It used to be one processor. Today, there are hundreds of processors in one chip, at least tens in many of the chips, right? And then there is a different sort of processor. There's a vision processor, graphics processor, neural network processor. So the chips have become complex. And once the chips are becoming complex, the verification also becomes very complex because the use cases are huge. Those days we used to have 100 use cases, 200 use cases. Today, it's millions of use cases and the combinations possible. You won't be able to hit all the possible combinations. So that is why we have to be clever and focus on the key areas where we can test and ensure that all the important use cases first are verified, and then we make sure the key criteria for the sign-off, like functional coverage, code coverage, are met. And if they are not met, we have to understand why it is not met, and we have to waive it, and then we have to go ahead, right? Now, what are the problems in design verification? Due to the increasing complexity, right? Huge amount of functional coverage. It's easy to write functional coverage model, but how do we hit it? And is it worth it? The return on investment is very important, because you can write huge amount of functional coverage, but is it really doing the return on investment from the verification economics perspective, right? I always focus on the verification economics and verification return on investment, verification quotient, right? Basically how we have EQ, IQ, there's a verification quotient. It's a very balanced approach, right? Last 0.5%, really, do we have to spend 2 months to close it? Is there a real bug left? It's a judgment finally when you do it, right? That's how it is. So what are the coverage problems, right? You can write cross many things, right? When you're writing functional coverage. Functional coverage, just to give a very important, why functional coverage is important. Functional coverage is directly related to the spec. From the spec, we decide this is the functional coverage we are going to cover during this process of verification. And now, what do? We have to make sure we have to write right amount of functional coverage, and then we have to cover it appropriately. So to do this, how AI/ML will come into picture? Because it can understand the functional coverage model and it can understand the stimulus model. In the verification, there are 3 important parts. As always, we all know, but I want to re-emphasize. One is the stimulus, second is the checkers, third is the coverage. To make sure the coverage closure happens fast. There should be a feedback loop from the coverage model to the input, so that it should be intelligent enough to understand that some of the coverages are already hit, and it has to understand, do the gap analysis and feed that into the stimulus engine. Now, in the old manual world, we used to do it manually, see it, analyze it, triage it, and then do it. And we still do, most of the time, we still do manually. But some of the AIML concepts, some of the AIML agents, some of the AIML will help us to fine tune it, and it will automate the task. The key thing of AIML is always remember, it will automate the task and it can scale easily. Most of the times, why there is a delay in completion of the design? Because you find the bugs in the last minute. Some of the yardsticks I've used when we are doing the sign-off is, one is functional coverage 100%, code coverage 100%, and when is the last bug found? Normally, when you find the last bug, we need to run the constant random verification for 2 more weeks just to get that confidence that there is no bugs left. So more later you find the bugs, I think it will start affecting the confidence and the sign-off will be delayed. So it is very important to find the bugs as soon as possible, as early as possible. Then the bug curve is very important, because then that should show the confidence, that should show the quality of the design, the robustness of the design and the verification environment. It's very important. So that is why earlier we find bugs, it's much better, so that towards the end we don't find bugs. Of course, it is better to find the bugs in the simulation than in the chip, but it's better to find it early. Now, tuning of simulation. This is very important, very, very important, because how do you tune the simulation to be effective, efficient, and making effective use of all the resources, computer resources, human resources, all the things, right? What do you do? So, as I told, there is a functional coverage model and there's a stimulus generation model. There are different parameters we do in the design, right? We have hundreds of parameters in the design. We have got hundreds of parameters in the verification. We have to make sure we are not investing the time and energy, the computer resources, into the areas which has been already been tested and we know that it's working. So we have to ensure the focus is on the untested areas. And how do you know it is untested? Functional coverage and code coverage are the great tools to analyze from the functionality perspective and from the implementation perspective, which are the coverage gaps and where we have to focus our efforts to uncover the final bugs left. Always I say verification is not only about finding bugs. Many people can find bugs. Yes, it's important to find the bugs, but it's important to say there is no more bugs. That's more harder question. When a verification lead, verification director, verification VP should always, it's very difficult to say for them, there is no more bugs. We can say we have found 100 bugs, 200 bugs. Yes, sometimes randomly, sometimes, some of the tricks, multiple random reset you do, you will find many bugs. We know where are the problems, but can we say confidently whether this design has got no more bugs? And also now the latest thing is whether it has got a good performance, right? Does it perform? Performance verification. Does it perform according to the needs of the system, according to the spec? And does it work according to the spec? That's very important. So from the AIML perspective, you have to tune the simulation environment so that you are effectively using the resources. This is one example I've taken. I think this is very, 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 very clear and very, very simple, right? It's just a block diagram to show how the knobs work. Knob is nothing but a parameter selection. Okay, it's a fancy word. It's a fancy word. Knobs, you have a 8-bit, 16-bit, or you can randomize different sort of packets, different modes in the chip. Those are all control knobs. Then you can randomize it, or you can control it towards the area, semi-constrained random area, so that you can get the output. So I've already explained what is really the flow, because this is a short presentation. I will not go in detail. I think at different point it can be done, but you should basically you have to use to have that feedback loop from the functional coverage models to the stimulus model, so that you are navigating towards the right area where design is not tested, and also in an efficient way. There is no point in, good example is mux, right? We'll take a simple mux, 8:1 mux. Once you have tested a couple of combinations, there is no point in hitting the same combination again and again, because you've already tested it. So, but when you do a constraint random simulation, randomization may keep hitting the same things again and again. So we need to make sure that we are efficient and start hitting what is not verified. This is where ML will come into the picture. That is where, this AI, ML, that is machine learning, deep learning, it'll learn and then it'll try to tune it. I want to just touch upon a few basics here, just for the people who have not. What is artificial intelligence? A big umbrella, right? In fact, there's a joke, right? Artificial intelligence is nothing but, we used to write if-else statement from 25 years. Sometimes it's become so popular, even an if-else statement, they say it's an artificial intelligence. It is nothing but, artificial intelligence is nothing but a huge amount of coding and then some learning. It learns from the past, basically, right? It basically learns. The greatest example I always tell is, artificial intelligence, greatest example is like when you're seeing a Prime Video or a Netflix, based on your past choices or past movies you have seen, it will predict these are the things you may like. If you have been seeing all about action movies, it will suggest this is the action movies you may like. That's a great example of, it has seen your pattern, it has learned what you like, and then it is predicting it. That's a great example of a artificial intelligence system, right? It will tell this is what you may like. So that is what is artificial. Under the artificial intelligence, there's a lot of branches. One of the branches, what is important is, okay, we'll go to the purpose of the AI. One of the branches is machine learning. That's where we are going to focus. And then there's a deep learning. What is the purpose of AI? The purpose of the artificial intelligence is to aid human capabilities and help us make advanced decisions with far-reaching consequences. It's basically used to scale, improve the efficiency, as we discussed, and to predict based on the past. It's like a human mind, right? When we were born, we didn't know, but by the environment, by our education, by our experience, by interacting with many people, we have learned what is good, what is bad, how we have to be efficient. And that is what we are trying to teach the machine, to learn from the past, learn from the previous interactions, and then behave more intelligently, right? I saw a particular video about a robot, robot in the, predicting cooking robot, but it can predict how an angry robot, right? It has been seeing person being angry and cooking, and then the robot also learns to be angry and cooking, right? So it can learn, but that's very important. One of the deeper thing is, you have to train it properly. Training is a very important aspect of machine learning. Now let's see the applications, right? We know we are trying to focus on our areas, like, in the ASIC design, but in the broader perspective, there's a lot of applications for AI, huge applications. We are seeing it in the life sciences. We are seeing it in the chemical reactions, pharma field, every field of business, everywhere. But today our focus is on how do we apply it to our field of ASIC design and verification. Mainly what happens is, it deals with the data, right? It's optimizing the search, right? And it is making sure it is detecting the patterns, and it is working on the algorithms, built-in algorithms, right? There are a lot of ML algorithms. It's already done by huge research, and this, we are reusing some of it. Then sometimes we are customizing it to learn and do it. Okay. So from the AI, we'll come to a specific branch, machine learning. What is machine learning? I have already explained. Machine learning is a branch of AI and of computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. So accuracy is very important, okay? Having been part of different AI/ML projects, to get a good AI/ML accuracy is a great difficulty. People who have really worked in the product systems of AI/ML, they will tell you. For example, there was a system to detect the face in the group, right? It takes enough of data to learn and predict and accurately predict that this is a person, right? You can see this happening in the Facebook already. It can detect you. It can suggest this may be the person, right? So accuracy is important. Most of the time it is in the range of 95 plus, but to get that 100% accuracy, it's really, really difficult. That's why it has to be trained on the right amount of data without bias, right? That is where the machine learns, and we have to make sure it is trained correctly so that it is useful for us. Machine learning is all about predicting the future based on the past. It cannot think innovatively, right? People are trying to teach, but machine learning is basically from the past, whatever it has done, it can do some combinations, it can, based on the algorithms, it can act, but it cannot innovate or creatively think, but they are trying to teach it. But how it is work is, it's just a combinations, right? It's just a combinations. How machine learning works. Machine learning algorithms are very important, right? Sometimes from the computer science background, they will understand algorithms are very important. There are complex algorithms are used to make a prediction or a classification. Error function serves to evaluate the prediction of the model. Model optimization. Model can fit better to the data points. Basically, you have to make sure the model is optimized for your particular application. In the world, we have seen many things in the image processing, for the security they are using it for any analysis of the sports. It can be used for many, many different things, right? In the research field, to identify and detect, see, some of the medical illness very early based on the data, huge amount of data you have it these days because of the scannings, because of the things, to detect the illness very early and to predict based on these things, you can have this problem. It's a very important research going on to detect the illness very early. That's one good example. But in our field, I think this is mostly, as discussed, it's helped in the coverage closure, optimizing the process from the design phase, verification phase, and making sure we are more productive. It's a productivity tool at this point, and then it'll help us to be more, it may be at one point, and it's always a dream that I will click a button, it'll automatically create a verification environment for a design, it'll automatically create stimulus, it'll automatically create coverage model, automatically create checkers, and automatically it'll say that design is verified. It's a dream. I don't know when it will happen, but it's always a verification engineer's dream to have a single button push button verification done. Then I always say, if that is done, then there is no need of much verification engineers. But anyway, we are many, many years away. We need more verification engineers, more designers to do so many chips, what's happening in the world. Deep learning. I just wanted to touch on the deep learning more. I will not go through. Deep learning is a class of machine learning algorithm, the form of a neural network that uses a cascade of layers of processing units to extract features from data and make predictive guesses about new data. It's like how your brain works, right? That is what it's all about. It's deep learning. It goes deeper, sees the data in different layers. It analyzes it, processes it, and helps to do a predictive guesses. Right? Then you would have heard about convolutional neural networks and recurrent neural networks. There are a lot of things. We can have a separate session on these things, just on the AI/ML. But basically, deep learning is training and making the large sets of labeled data and neural network architectures that learn features directly from the data without the need for a human manual feature extraction. Basically, without manual intervention, it is trying to learn and apply and help us to be more efficient and do the work what otherwise we have to do by automating the things. I think this all of you know what is ASIC design and ASIC verification, right? Just for the sake of some people who are new to the industry, I can say basically design we do using Verilog, VHDL, and System Verilog. And in the design phase, normally the coding is less. Normally the verification engineer does twice the coding. Design development is mostly about seeing the specs. First of all, it starts from the top macro level specs, then it goes into microarchitecture, then you do the coding. There are a lot of helps available. Templates are there. Many templates are there. It can help you. We can do a lot of checks while developing, while constructing the code itself. You can have, that is called CI/CD, continuous integration and continuous development. Correct by construction. You can do a lot of formal checks initially. You can do a lot of checks of AI/ML agents. You can write whether they are following the coding guidelines of the project, coding guidelines of the company, coding guidelines of the industry vertical, or coding guidelines of the compliances certain industries like automotive or like defense, space, aerospace. So you can do a lot of things by putting in a lot of processors and agents, AI/ML agents, very early in the cycle, okay, in the design. In the verification, whatever is designers developed, we have to verify it and make sure it works according to the spec. That is our responsibility. And on the way, we find many bugs. Finding bugs is not our goal, but it is a side product. Again, coverage, code coverage and functional coverage are the getting the good functional coverage, getting the good code coverage is our, yes, it is our one of the objectives, but it's not the end objective. Our end objective is to verify the design properly, having the good functional coverage model, and keep on, it has to keep on increasing because managers will be always happy to show the good functional coverage, good code coverage. Yes, it has to keep on increasing, but that is a side product of the good verification. It is an indicator telling that product verification is progressing well, but it is not our objective or the final goal to show 100% functional coverage, 100% code coverage. We don't tape out functional coverage model. We tape out chips. The chip has to be verified and it has to work in the field. So yes, we have to give importance to the functional coverage, code coverage, but we have to make sure our primary goal is to verify the chips, and it has to work when the chip comes back, and then it has to work in the field. What is happening? Probably I'll take 10 more minutes and then we can stop for questions. Problems in the design and verification is there's a lot of IPs. These days we have a lot of IPs, already proven IPs. We're integrating IPs. Sometimes the last few chips I worked, it had hundreds of IPs from different vendors in the world, all over the world. IPs are coming, IPs are pre-verified, but we don't know when IPs are working together whether it will work properly or not. Clock speeds are higher. There are multiple clock domains. When I started my career, there was only a single clock domain, maximum 2 clock domains. These days there are hundreds of clock domains. Okay, high speed. When we started with megahertz, right? Maybe few people would have started still early, but nowadays it's all gigahertz. Speed, very important, and combinations huge. There's a network on chip inside, there's a multiple processor, there's a housekeeping processor, there's a vision processor, there's a graphics processor, there's a neural network, there's customized IPs, there's a DSP, there's a huge amount of communication protocols, Ethernet, name it, PCI, USB, name it, you have it in the chip these days. Low speed peripherals has been there for many years. But what happens is the complexity increases. So now to start to summarize, right? Major time is spent in the verification. We all have to agree 70% of the project is verification. So we should focus on that area where we can get the good productivity, right? And then how we can make sure we are more productive. We are using the latest and greatest technology to make chips better, chips work. One of the other data I remember is lot of times, many times, the first time silicon success is not happening. So our goal is to make sure first time silicon success happens. We have got engineering sample 1, engineering sample 2, and then finally the production version. Most of the time there's a bug. Then we have to do the respin. Then we have to do that. It's a lot of expensive and the time is lost. So we have to make sure our goal is to have the first time silicon success. Sometimes the bug escape happens, but sometimes you're lucky to have a software workaround or that feature is not used. But if it is on the major area, then you have to use chip as a pendant. Debug, many times the debug, you can use the AI/ML to help you in the debug, to accelerate your debug, find the problem root cause. There are a lot of ways to do it. Many companies are working on it. A lot of ways to do it. Let's skip this. There are types of bugs. I think most of the people know many types of the bugs you will find. Design bugs, connectivity bugs, timing issues, traditional debug flow, complexity in debug, right? Because there's a lot of problems in the debugs. And in the verification, you spend more than half of the time in the debugging. So we have to make sure that we are using the right tools in the debugging to make sure we are efficient. And debugging is very hard because there is no single methodology for debugging. And debugging depends upon each person, each team, how you interact. Sometimes I found I was not able to debug at all, but suddenly my friend who can come and just say, oh, no, this is what is happening. You can find it out. Are we asking the right questions? Are we using the right tools? Methodologies is very important. There are many companies who do this. Right? AI is providing the improvements to the debug process, right? Supporting with the different waveforms, back, you have seen all the simulators give a lot of features these days. Read the VCDs, read the logs, read the many different parts, all the data you read and try to find where is the root cause of the problem. What are the important parts for the debug? The problems can be there in the design, it can be in the verification environment, it can be in the EDA tool, it can be in the VIP. So focusing to find where can be the thing is the first point. It's the art of debug. Most of the time it comes with the experience. Then by interacting and by going through some of the process, some of the debug papers, it will help you. Let's start winding up, right? What are the advantages with AI approach? Where are the areas? Now, if you see broadly the design and verification, now we have already spoken about functional coverage closure, debug, developing the design code, spec generation, sometimes spec to templates for the design or verification, from the code to the spec. Many areas you can use AI ML. Regression monitoring, right? You can use for classification of the bugs, to assign the bugs. You can use AI in many different ways. But many companies are working on the different problems and trying to solve it. And it is up to us as a project team to identify what is the best tool set, best methodology set for the specific chip, right? Different domain chips require different approaches. Like, AIML chips requires different approaches, automotive chips requires different approaches, NOC requires different approaches, communication chips, wireless chips, telecom chips requires different approaches. So we have to, for the particular chip, what is the right approach, right set of tools, flows, methodologies we need to approach. And then we can start seeing what are the AI ML based tools, methodologies available and try to plug it in. Many companies, many startups, scale-ups, big EDA companies, all are working on the different tools to integrate into the system, from verification planning to coverage closure. This is what happens. Okay. Role in the coverage analysis, I think we have understood coverage, and this is just a block diagram. I've given it again here, how you run the tests, generate the DB, manual analysis, and then we do the thing. If you apply the ML, you replace the manual analysis by the ML. You can analyze it quicker. Debugging, we have discussed. Okay, one of the slides I want to take is, sometimes many people think AI, ML, or AI is just a magic wand. It can do all the things automatically. A classic example is Tesla, right? They have spent billions of dollars. Still, they are not able to get a fully automated car. Why? Because the challenges are huge. The use cases are huge, right? So we have to understand that it is like any product, any technology, it will take time to mature, time to understand it, train it, and apply to a specific set of problem. It is not a magic wand. So you have to understand it. There's efforts required to select, apply, and use it appropriately to get the advantages of the AI. Some of the misunderstanding in the AI is like, expecting AI to do all the work. Some people say, oh, if I use AI, then I don't have to do any work. I can sit and see cricket match, right? Right? That doesn't happen, right? So we need to make sure AI is used correctly. Some of this I have here, trapping user in bubbles, failing to optimize processing time. Other important thing is AI. If you allow AI, it will use huge amount of power and resources, right? And it's a lot expensive. If you really see, if you're doing a machine learning processing in the cloud, if you start putting the dollars and money, it can use many thousands of dollars for processing something, for image processing, for processing the data to do the thing. So you have to be careful. Power is very important. How much resources it's using, the processor power it's using, GPU power in the cloud. So we have to be careful about utilizing ML appropriately and in the efficient way. Just to find out what is the next movie you have to see, you can't spend 2 hours ML processing, which will charge you 100 pounds in the server to do that production. As well, we can see the option. It's a semi-automated is where is the good judgment, and semi-automated is the where we see a good right fit today, as of today. Okay. Conclusion: AI/ML is a good technology. Semiconductor is booming. Complexity is there. We have to use the technology AI/ML in the design and verification cycle to make sure we are efficient. We are making sure we are focusing on the right areas for design and verification. We are using the right tools, flows to make the good chips, first time silicon success, to make the lives of the RTL designers and verification engineers better, helping us to be productive, helping us to be also consistent across the teams. It will help us to have the knowledge share developed in the company sometimes, right? The knowledge learned from the previous bugs, for example, knowledge learned from the previous processes, it can be all embedded and make it as a company database, company knowledge, company IPs in terms of machine learning. The machine learning software can learn on derivative projects, old simulation data. So it will all have the data, and then it can learn and it can try to help us in the future. This is all I have. I will stop here and give you a chance for ask the questions. I think that will be more interesting. And then we will take it from there. I will stop the screen sharing for now. Adarsh or Rahul, please maybe, help me out with the questions, and then we can start answering the questions.
Thank you for this session. It was very nice, and you actually kept it very precise and short, and it was understandable for the students as well as me being from outside the industry. I was able to understand it. So, and we have multiple questions from the students. So one by one, I'll go through it. I'll read out the questions to you, and then you can go ahead with the answers. The students are waiting. So the first question is from Vinod Bandela. So he has asked, question from Vinod Bandela is, when we write the functional coverage for an asynchronous FIFO where the concurrent read and writes are done, the coverage is 92%. It is not hitting 100%. Is it good to go? Because full build is not hitting. You want me to repeat the question?
No. I understood. In general, any functional coverage, right? When there is a gap, we call this a functional coverage gap analysis. You have to understand in real world, will that scenario will be hitting? If that is not a realistic scenario, we have to do it as a waiver, we call it as. You can waive off that functional coverage by talking to the designers. The best process for a waiving off is you have to go to the designer, not verification engineer. Verification engineer should go to the designer and say, this particular scenario is not hitting in the design. It may be due to various factors. Maybe that scenario is not hit. Then designer will think either there can be a bug in the design. Sometimes it is uncovered. Sometimes the functional coverage model return way may be different. Sometimes you have to understand, discuss, and say, okay, if it is required, still, if he says, oh, no, it is correct, but you're not doing the stimulus correctly, then stimulus may not be correct. We have to do it. If not, if it's not really not hitting, then you have to talk to the designer and waive it and document it. Remember this. Whenever you waive some functional coverage or code coverage, please make sure you document it, because in the future, if the chip comes back with a bug in that area, they will ask, who is the verification engineer? It is not only about that. It's a good practice to waive it and document it so the seniors will see, seniors in the hierarchy will see these are the things waived, and the seniors may find, oh, why this is waived? No, it should happen. So in your case, you need to go to the designer and ask why it is not. First of all, you have to analyze, is there a possibility to hit it? Why it is not hitting? Did I code it correctly or not? Yes.
Thank you, sir. And now the next question is from Nagela. It's a very simple question. How to get a job in design and verification?
Very, very interesting question, right? I was expecting this. It's good. If you see, my whole presentation was about that. That's why my first slide was what? Okay, one of the advantages I have is, in my experience of 20 years, 5,000 engineers have been trained directly, indirectly through me, right? Not directly. When I ran my companies, I hired and trained, and they're all there. Very important thing is be good in your skill, okay? Be good in, if you want to do a career in RTL, be good in Verilog and System Verilog. Verification, more opportunities are there, more challenging, more opportunities, more number is needed. You have to be very good in System Verilog and UVM. I'll give you one technique. If you're learning System Verilog and UVM, code 10,000 lines of code before going to an interview. You will definitely get a job.
So I think you just answered two questions at once, because next Manjunatha's questions was this only, which skills are important? So
System Verilog and UVM, be very good at that. Do different examples like APB, AHP, Try to do a risk 5, some examples. Risk 5 is very important. Do some projects. Nowadays, you're all blessed. You have an EDA playground. You have got many things to go down. Do it. Please play around. Do code. Produce code. It's like agricultural people producing the agricultural products, crops. You are producing the code. As a verification engineer, design engineer, what are you producing? Either a code or a design document. Produce. Be good at that skill. No one can stop you from getting it, but you have to be good. And you have to learn in the right way, in the right manner, get mentored properly in the right areas. Nothing can stop you. There's a huge opportunities in India, in abroad for those skills. I can guarantee you for next 10, 15 years, there'll be so many chips. There's a huge skill shortage globally.
Like as you yourself got the opportunity to work in US, Russia, currently you are working in London. So I think you have been following the same.
If there's a good trained engineer, there are 100 companies that are ready to recruit.
Yes, very nice. So the next question is from Arun. Which is the best AI tool?
There is no simple answer. It's something like asking which is Pepsi is better or Coke is better. Can we tell me? Or BMW is better or Mercedes is better? It is all perception and also right tool for the right cost. And also, people sometimes, I always give a classic example, right? In Bangalore roads, there is no need of having a Porsche car, which will run at 300 kilometers per hour. Can you run in Bangalore road 300 kilometers per hour Porsche racing car? No, right? There is no need. Even if I have that car, I don't think I can run at 300 kilometers per hour. Any road, except Bangalore, Mysore, maybe. Right?
Yeah, highway.
Highways. So, right tool for the right purpose with the cost and the robustness. You have to understand. Sometimes people have got huge aspiration, but their budget is very less. I always say to the customer, you need Porsche always, but you're giving me, cycles budget. With the cycle budget, you need to buy a Porsche. You get what you pay for, right?
Yes, exactly.
But there are open source tools. There are different tools, many, many different tools. All the EDA vendors are doing well. Okay, you have to only pick it well. We have to be EDA neutral. Whichever company, that's okay. Every EDA tool is good. You have to make sure you have to use the right tool in the right way. That's it. Every car is good. Right? Yeah.
Utilize the resources well.
Well, efficiently, productively. Learn it well. First of all, even if I can give an example, in your own iPhone or Android phone, do you know 100% features of that? No. People use only 10% of the feature. First of all, even if I'm sure in my own car, I don't know all the features of my car. Because there's no time to read all the manual. So please understand it, read it, then utilize it.
So we got a second question from Mr. Nagela. He says, Sir, what are the steps involved in chip verification?
Yes. First is verification planning, then a verification environment development, then verification code development. You can develop the stimulus, functional coverage model, checkers. Then you start the regression, initial regression, then nightly regression, weekend regression, long regression, full regression, and you have to do the coverage closure, and then coverage wavering, and then review and sign off.
Great. So the next question is from Arun. It's an interesting question. How quantum computing is related to VLSI?
A lot of technologies in chip design is going to be used in quantum. For example, error correction, error detection. Quantum is not, a lot of people are investing. It's 2 years, 3 years away from being stable. Google, NVIDIA's, all of them are doing. There's a quantum national mission. A lot of things are happening. There can be a hybrid chips between the silicon chips and the silicon photonics. There is a silicon photonics coming. Then there's a quantum. There can be hybrid chips coming up. So that is where semiconductor will be interacting with that.
Okay. So we have a question from Vinod Bandela. Is it mandatory to learn this ML coding and deep learning, or rather just use GPT tool to understand the error?
It's always important, right? I can tell you. Is it okay? Let's take you are learning some English. Is it okay to just use GPT instead of you learning English?
No,
right?
exactly.
You need to know English to converse. If you're going to go and get married, boy or girl will ask, how do you converse, right? Today, Adarsh is hosting very well. Others also can use the ChatGPT of, using good English, good communication skills. You have to learn. At the end, ChatGPT is a tool. Use it to improve yourself and be good at it, whatever you're doing. But you cannot replace ChatGPT always.
Yeah.
ChatGPT is a tool.
Yes. It's up to you how you utilize it and how much you use your skill.
You can come to a course, right? Chipet just now told. You can go to a course. You can do different things. But finally, that's a means to an end. Just, you have to be a good engineer, good verification guy, good leader. You have to apply it.
Execution matters.
Yes.
So next question is from Pasupati KR. Which AI/ML course will be more useful for a design verification engineer? Is it a machine learning or a deep learning or data science?
I think it's a combination for a different problems. I think a basic knowledge of all the three is important. It is like telling um, to drive what skills are important, seeing or your motor skills or
Motor
your
skills.
this thing. So you need to have all the three. But I think ML will be more useful initially. To start with the Python, it's nothing but using different packages, libraries. Start with Python, start with languages, and then start using some of the libraries, language models, and then I think then select a problem area or a pain point, and then see in that area what you want to apply. So there is no one solution for all the problems. There's a customized solution for a particular problem. What problem are you trying to solve? And then see how we can use it.
One question is course related, so we can skip that. We'll be asking them to fill the form directly. I have skills I need. I have skills I need an opportunity to prove myself. Can you give me a chance, sir?
It's a very interesting, right? See, for people like Chipe, there are many people calling you for interviews. Always, it's see, if you, I will tell you a secret thing, right? I told you 10,000 lines you code and go to an interview, they'll give you an interview chance. Opportunity will come. Sometimes, yes, sometimes it may be delayed. We all go through the different cycles in the industry. Sometimes you meet so many people, there are not there. Sometimes it's a little bit quieter. Like Christmas time, it's quieter. Like December, no one hires. January, they'll start hiring. Sometimes in Europe, summertime, they'll not hire. They're all on a holiday mode. Sometimes the
Yes.
budget opens up in different times. In the December, it opens up. On the March, it opens up. In India, it is financial year is from April to March. After the April, suddenly there will be a budget. Then they will start hiring 100 engineers, 20 engineers. But you have to keep applying. Please follow LinkedIn, follow all the job sites, follow your user, improve your network in the LinkedIn. That are a few tips, but opportunities will be there. 100%.
The more you engage with the peers from the same industry, the more you grow.
Of course, and then you will know more higher you grow, most of your jobs come from your reference and network.
Right. Next question is from Edika Susila. Sir, explain me about the chiplet technology.
Yeah, chiplet is like, if you remember Lego, you can put different Lego boxes together and do a chiplet. Why it is required is how we used to do, a lot of IPs are there, and we used to integrate and make the chip. Now what they have realized is sometimes we cannot put all the functionality in one chip. So it is better to do, for the purposes of economy and purposes of the commercial aspect of it, you do a different chip and then connect to each other chip, so that then you will, what happens is, from the big product perspective, you need multiple chips. All the chips you do not have to do. Some things you can buy. One thing is your secret sauce you can do, connect all other standard things. See, by doing an already existing chip, you are not offering anything differentiation. So you can buy those chips. For example, you want a system of 9 chips. You buy 8 chips and do only your customized chip, and you connect it through chiplet. You cannot put in one chip. Sometimes it's too. That's why it's a chiplet comes into picture, and UCI product.
Okay, sir. One question we have from Dr. Saswat Kumar Ram. Is it mandatory to be familiar with AI ML for VLSI engineer as per the market needs?
Not now, but it is good to have. It's nice to have. It is very nice to have. Believe me, if you have AI ML plus system log and UVM, you have a better chance.
Okay. And next question is Krishnendu, who has asked how AI ML can be used in RTL design. Have the semiconductor industries already started using AI in RTL design and tool flow management with FE and BE tools?
Yeah, front end and back end tools. Yes, they have started with many tools. You see the top to the EDA vendors. They have already incorporated in the continuous integration, continuous development, RTL templates, spec generation, spec quality, monitoring, initial check-in, many different places. But it is in a different stages, because it's a quite continuously evolving stage. AIML, it is not stabilized. It's not an old technology. It's not like a commodity.
Yes.
It's like evolving. Everyone is evolving. Everyone is doing their own recipes, own research, own product deployment. Every quarter you hear something new, but it is started already.
Next question is from Vinod. The FIFO in my personal project, sir, With UVM, I got asked in the interview that why 92%, why not 100%?
Yeah, definitely. You should have 100%. If you get 92, you talk to the same question he's asking again. You should go to
Yes.
the designer and ask to waive it off. Then it becomes 100. Otherwise, you have to hit in such a way that it should achieve 100%. Without 100%, you cannot sign off.
He has a follow-up. He's saying my answer, which I told, is because of concurrent read and write, the full bin is not hitting. That's why
Yeah,
it's only 92%.
Then
Am I
you
correct?
need to waive it. Then you have to waive it, because if the concurrent, first you have to ask the specification guy, is that scenario possible? And it is not possible because it cannot happen. Then you should not, first of all, while developing the functional coverage model, should not write the case. If you have written it, waive it off. Tell it is done and close it. And with the documentation.
It's good to see they are posting different questions. Krishnendu has again asked, just like how we code and learn system Verilog UVM in sites like EDA Playground, is there any free tools where we can use AI ML in our current job and learn the possibilities of AI ourselves?
100%, there's a lot of tools. If you Google, you will find there are free courses. But see, remember, free courses, I will tell you very honestly, free course, it's something like, there's a YouTube, then you don't have to go to college, don't have to go to engineering college, sit at home and study. But how much time you will take? The value what the education system, value those training institute, value the mentors, value the leaders come is they'll give you the curated. For example, I have taped out 20 chips in my life. Can you ask ChatGPT 20 chips it has done? And can you get that experience? No.
Exactly.
You need to get the for example, a particular course, system Verilog course, if you keep on Googling ChatGPT, you will take 3 years to learn. Instead of that, isn't it better that you spend time with a good mentor, good trainer, and learn it quickly within 3 months or 6 months? You can learn everything in the internet. I can also do MBBS in the internet. Like, nowadays we do, right? Before going to doctor, we Google what we can do. So that I can put Google doctor. But when it comes to your life, will you depend upon Google?
No, we'll visit the hospital, take an expert advice.
Exactly. So, but there is no harm in having knowledge, but use all the sort of possible. See, for example, I am not a professional doctor, right? I can learn about medical. If I have got extra time, I'm bored with system Verilog UVM, I will go and say, WebMD, what can I do if the fever comes? Paracetamol. I'm not going to practice on that. I don't have to go to medical college to do that. But for a system, if I want to learn the next technology, if it helps, if I want to do my career, I will definitely not depend on Google. I'll learn basic things, but I'll go to a specific course. I've done it in the technology, I've done it in the business, I've done it everywhere. It is important to learn correctly from the right people at the right time. The productivity is very higher.
And I think it's not limited to VLSI industry. I think this goes for everything. Everything,
right? I told you communication skills. One of the important things, I think, communicate. How do you communicate is so important. You have to I keep improving, right? I'm already reaching 50 this year, right? But still, you have to improve. Every time you improve, you start seeing our external affairs minister, wonderful communicator. He has spent time. The champions always spend time to improve their skills, improve themselves continuously. Champions after the Olympics, if you see, they don't come home and rest. They start again for the next. That's important. In anything, it can be in a system Verilog, UVM, any world. Then that is what the champions are. See our cricketers, right? Virat Kohli. After IPL, he'll go and practice again because they have to play for World Cup now. I hope he plays well in the World Cup. But still, the champions always, they are continuous improvement. See Sachin.
You keep on practice, you keep on meeting the right people, you learn.
Exactly. And you have to polish it.
Yes. Next question is from Suman Kumar. I think this is the last question. Do we need to LLM for RTL design, and is there any data set available publicly?
Not available, and I feel, this is my personal opinion at this point, RTL development LLM is too much. It is something like this, okay? I will tell you, it is possible, it can optimize later. For example, I will give a good example. Let's say you want to do idli. All of you know idli? In India, idli, yes, idli. Can we ask LLM to do idli based on the training? It will do, I'm sure it will do some idli, but it will not look like idli. If it has to do idli, I have to train in so many good idli restaurants like MTR. I know Bangalore, right? I've been in Bangalore. And good idli restaurants, train, and then finally it will give good idlis. One day, maybe we will have a robot who's trained on the ML to do beautiful idlis, standing on the roads instead of the people and doing idlis and giving. But it takes a lot of time to do it. Is it worth that effort? It is like, if I have to pick up one card, should I get a crane to pick up this up? You have to use the efficient tool. But yes, it is good to think about it. At one point, LLM for RTL will happen, especially within the companies. Specific verticals like automotive, consumer electronics, vision, it will start happening because it will start training on the previous IPs, previous thing. Specific, but not 100%. Some part it will help you to, you don't have to start from zero, it will give you 50-60%, then you can make it to 100%.
Great, sir. And I think those are the questions. It was very nice speaking to you, and I think this was a wonderful session, sir. And even though because of these webinars, I get to interact with a lot of industry experts, and I had been interacting with you for some time, and I've seen you over LinkedIn. So I would request all the people to do follow him and follow his work, and I'm sure this will somewhat motivate you to grow in your career as well. And for anything with regards to your career opportunities, anything, you can connect with us. You can fill our inquiry form, connect with us. We'll get in touch with you. We help you as much as possible to excel in your careers. And thank you very much for joining. Let's end this session. And
thank you very much. Thank you, Adarsh. You have hosted wonderfully. Thank you, Rahul, for a kind introduction. And thank you all for attending and your time.
So thank you so much, Mr. Paul. That was a wonderful session. So now going forward, I will move on with our offerings, what we have for students as well as for working professionals. So let me share my screen now, and I will start explaining you about our offerings, Chip Edge. So talking about Chip Edge, we are a VLSI skill development company, and we are here in this industry for more than 12 years. Okay, so about Chip Edge, we are founded in 2012, and we are into this industry for more than 12 years. And we have trained close to 4,500 engineers, and we have 200 plus hiring companies. And we offer placement support, which is 100%. Right, so these are our program offerings. So we have programs for students and freshers, for professionals, for enterprises, and for educational institutions as well. And going through the programs, we offer VLSI certification courses, which is offline in classroom, where students, the final year students or the fresh graduates, can come here and join this program. This is a 6 months intensive program for physical design and design verification. So coming up to the next thing, we are conducting an admission test, which is CVAT 2020-2024 for physical design and design verification. So this is the registration link, and I will ask my colleague to share the registration link as well in the chat board. So whoever is interested to participate in this test can register themselves. So the best part about this, we'll offer 80% scholarship for like best scoring students, and there is also an option to pay after placement. So there are 2 batches we are running for physical design and design verification. The first batch will be on 10th June, and second batch will be on 8th July. So coming up to our next offering, this is internship for students in BTech and MTech. We have internship models for 4, 8, and 16 weeks. The specializations offered are RTL design, design verification, design for test, physical design, and analog layout design. And the students from 3rd semester from BTech and 1st semester from MTech would be eligible for doing this program. So whoever is interested for this program can drop a message in the chat board. Coming up to our next offering is multi-semester model. The duration would be from 3rd semester to 8th semester. There will be a 2 to 4 weeks of internship after given semesters, which is 4th and 6th, and 12 to 16 weeks of internship in the 8th semester. And all the projects what is offered is industry relevant projects. So the next model what we offer is faculty development program and workshop model. So this is offered to faculties who are teaching to the students. So this for this, we are offering it from 1 to 4 weeks, and these are the specializations offered. So RTL design, design verification, design for test, physical design, and analog layout design. So these are the live online weekend session courses. We offer physical design, design verification, and design for test courses. This is live online. This is conducted on weekends, and it is delivered by industry experts. And these are our few upcoming weekend courses. We have our physical design course starting on 16 June, RTL design on 6th July, design verification on 6th July, and design for test on 27 July. Coming to our next course, this is self-paced courses, what we offer. So we offer RTL design, design verification, design for test, physical design, and synthesis. And we have our upcoming courses, which is formal verification, TCL scripting, and Python scripting. So these are our key features of our on-demand learning solutions. The content is developed by industry expert, and you can learn at your own pace and convenience. These are all recorded sessions, like both theory and lab. So whenever you want to hear it again, you can do it. So lab access on practice through VPN. So the lab is given through VPN, so you can access it anywhere, anytime in the world. So industry relevant projects are given. Training support for doubt clearing sessions is also given. So upgraded content with more features will be available from June. All right, so these are few of our on-demand courses. We have close to like 45 plus courses available. These are few of our courses. So coming to our partners, we have our own services company. It's Kaunds Semiconductors. And also we are partnered with IESA, India Electronics and Semiconductor Association. And we are an EDA partner of Synopsys. So these are our hiring partners. As I said before, we have 200 plus hiring partners. These are few of our hiring partners. So TCL, Synopsys, Meta Graphics, AMD, these are a few of our companies. So thank you so much. This is my contact information. So anybody having any clarifications or doubts, you can call, you can contact me to this number, or you can email me here. So in the chat board now, we will be sharing you about the CVAT admission test and also our registration page. So those who are interested to join a program or who would like to enhance yourself in the VLSI stream, you can apply it here.
Time is the most valuable thing,
Thank you
right?
so much, Mr. Paul and Adarsh, for like all these sessions you have given. So to all the participants, we have a news like we will be conducting this webinar sessions every month on the third
Yes.
Saturday. So you will be getting notifications through email as well as through WhatsApp about these sessions and about the speaker who is going to come. So like I encourage everybody to join for our upcoming sessions. So thank you so much everyone for participating in this session, and thank you so much for our speaker, Mr. Paul, who like gave us time early morning from London for for our enhancement of the knowledge. And thank you so much for others to making arrangements for this wonderful session.
It's my pleasure.
All right.
Yeah.
But thank you so much, everyone. You have a
Thank you
wonderful
and have
day.
a great day.
Have a great day, sir. Thank you.
Thank you. Bye.
Bye.